Welcome back, everyone, to our second portion of our interview with Chris Richards from Pro M Racing. Welcome back.
Thank you.
So, our first question is, what is the difference between mass air and speed density, and why is mass air preferred?
Okay, this will probably be easier to draw than to explain, so why don't we do a little illustration on the bench here.
Okay.
Okay, so this is mass air engine management. We have our mass airflow meter. The mass airflow meter is going to give us an air mass value. This would be the amount or the mass of air that's being ingested by the engine at any given time. We're going to take our air mass value, we're going to divide it by our potential for air mass. The potential for air mass is simply calculated by looking at your cubic inch displacement. Air mass divided by potential air mass equals load. Now, we're going to use load and RPM in a table to calculate an air to fuel ratio. And we're going to use load and RPM to calculate a spark advance. That's really all that engine management is. It really doesn't have to be any more complicated than that. If we know a value for load, then we know what our air to fuel ratio should be, and we know what our spark advance should be. Okay, so now let's talk about speed density. With speed density, we do not have a mass air meter. What we're going to do is we're going to use a value called volumetric efficiency. We will have a VE table, and we're going to use this VE table to calculate an air mass value. Now, we don't know what our VE is at any given time. We're going to look at RPM, and we're going to look at MAP, and we're going to attempt to fill all the values in this VE table with values that will give us a correct air mass value so that we can then do all of the same calculations we would do with mass air. It's really the only difference between mass air and speed density is that we do not have an air mass value that has been measured. We have to calculate an air mass value using a VE table. Okay, so mass air is actually very simple. We're simply going to take readings from sensors, apply those readings to some math within the processor, calculate a load. From that load, we're going to have our air to fuel ratio value, and we're going to have our spark advance. It's really that simple. With speed density, again, no mass airflow meter, we need to calculate an air mass value. Honestly, we do that by guessing at values in a VE table. So really, speed density is a whole bunch of guesswork and experimenting until you get values that give you the results that you're looking for. I would equate, as silly as this is going to sound, here's a good analogy for you. If I'm sitting here in my heated shop and I want to know what the temperature is outside, I can accomplish that one of two ways. I can either measure the temperature here in the shop, I can calculate the R value of the walls, I can figure out how efficient my heating system is, I can apply all those values to complex mathematical equations, and I can, with some reasonable amount of accuracy, calculate what the temperature is outside. Or I can walk outside with a thermometer and measure it. And, you know, think of VE as the R value of the walls. I'm going to guess and guess and guess at the R value of the walls until I come up with a number for the temperature outside that's correct. That's really what it amounts to. You know, the fact is that the OEM has not used the term VE for some time now. And the reason they don't use it is VE is crap. It has no meaning in engine management. VE is something that has meaning when you're talking about building engines. We want to make an engine as volumetrically efficient as possible. But VE, as far as it applies to engine management, is a meaningless value, which is why we're taking a VE table and throwing numbers at it until we get the results we're looking for. The OEM does not use VE. The OEM uses a relationship between manifold, vacuum, and throttle position to calculate air mass, and they use a mass air meter to do it. That's the fact.
Thank you for that explanation, Chris. Well, our next question is, Chris, is sequential injector firing necessary over batch?
Not necessary, but beneficial. At lower RPMs, using sequential firing, you're going to get better idle quality and you're going to get lower emissions. But up above 2,000 RPM, sequential firing really doesn't amount to anything.
Okay, great. By the way, Chris, congratulations on your new engine management system.
Thank you.
The reviews so far have been very positive, but everyone online wants to know why it is so expensive.
Okay, well, truthfully, it's not more expensive than any of the other systems that are out there that are worth considering. More expensive than the cheapest system, sure, but we're not even on the same playing field. You don't go test drive a used Hyundai and then walk into the Lincoln dealership and ask them why it's so much money. There's a reason it's more money.
Yes.
And the reason is OEM level electronics. The other guys are using low production aftermarket electronics. It's well documented that stuff is not reliable. We just had one of our competitors in the mass air meter business completely redesign their mass airflow meters because they had such a high failure rate. So you really can't beat the quality of OEM stuff. Our processors are made side by side with the OEMs at Visteon. The torture testing that they put those processors through, the quality testing that they put those processors through, you cannot duplicate that in the aftermarket. You just can't. They don't have the resources. They don't have the finances. You can't do it. OEM electronics are expensive. So we've got our OEM computer. We've got our OEM level USB box. The other thing is the wiring harness. You look at these other guys' wiring harnesses, it's not a wiring harness. It's a pile of unterminated pigtails that they give to you, and you're expected to build your own wiring harness. We give a complete wiring harness. In fact, in the case of our direct fit systems, like let's say for Michael's Mustang, this harness is massive. There's a lot of circuits in that harness. There's a lot of OEM connectors in that harness. All that stuff is expensive. That's it. That's the fact. Realistically, we should be charging quite a bit more for our systems. We just want to stay competitive price-wise. That's it.
So basically, you're letting us know, Chris, that quality is not cheap.
That's right. It's not. You start comparing us to the $700, $1,200, $1,500 systems. Bottom line is, when you're all said and done, you're going to spend the money anyway. One dyno session, $700, and you're going to be going back again and again. You buy one of our systems, you enter a few simple parameters, the computer knows everything it needs to know, you're done. We have customers out there that have made several changes to their engine combinations. Hell, I've done it to my own car several times without making a single change to the tune. So, you're either going to spend the money on a system that works properly, or you're going to spend the money on a system that really doesn't work very well in dyno tuning. There's really no comparison.
Great. I think that's a great explanation. Thank you. This concludes the second portion of our interview with Chris Richards. Thank you for joining us.